Yeah, I don't know if it's just me, but these problems are easier than the ones that I went over for the exam review for the old exam. They seem pretty straightforward. All right, so here we have an RC circuit. We see the switch had been closed for a long time and is opened at t equals 0. That tells me no matter what else the question is asking me, I've got a capacitor in here. I need to find VC at 0 minus. Okay, so anytime you've got this situation, you'll need that. If I had an inductor, I would need to find IL at 0 minus, because that's the one thing that cannot change instantaneously. So at 0 minus, we know that it had been closed for a long time. That means under DC conditions, a capacitor, given enough time, is going to act like an open circuit. So I want to draw T at 0 minus. I want to draw the circuit at T equals 0 minus. And the capacitor will act like an open circuit. And I need to find what that voltage is. I need to find VC of 0 minus. Well, this is pretty easy. I have a 2 amp current source here, and I would have done it. Okay, I'm looking. I said I would do it the way the solutions are doing it. So I would have done current division. So what? And I'll do it both ways. So and there's not that one way is right and one way is wrong. Is you just to get used to doing it, your own way. So current division would tell me that my current through this resistor would be 2 amps times the other resistor, which is 10, over 10 plus 15, which is 25, or 2 amps times, let's see, what is that? It's, 2/5, 4/5, that's 0.8 amps. And then the voltage will be V equals IR, is going to be 0.8 times 15, 40 carry the 4, 12 volts. Okay, so that's like just my instinct, how my gut, the way I would do it. But there are always a gazillion different ways to do things. And so another way to do it is to notice that everything is in parallel. And so since everything is in parallel, if you find the voltage across one of them, you know the voltage across all of them. And that's the same even if you find their equivalent resistance. And so our equivalent is product over sum, 10 times 15 over 10 plus 15, which is 150 over 25, which is 6. And so our equivalent resistance, this is 2 amps, and this is 6 ohms. And so now we would have this plus minus V equals IR, or V equals 2 amps times 6 ohms, which is 12 volts. And notice it is plus on top because that's the direction that current is going. The current goes from higher to lower, and so it is a positive 12 volts. Okay, so VC of 0 minus equals 12 volts. That means VC of 0 equals 12 volts because it cannot change instantaneously. So once you find A, you found B. So that's done. Okay, now we want VC at infinity. So I'm going to redraw the circuit. I'm going to just redraw the circuit at t equals 0, and then we'll extend that to infinity in a minute. So we're going to open this switch right here. And so when we open that switch, this middle branch becomes irrelevant right there. And so we have a circuit that looks like this. And this is 2 amps. This is R1, which is 10 ohms. And our capacitor is 2 millifarads. Now at infinity, This capacitor is going to act like an open circuit again, because infinity is after a long time. And so if it acts as an open circuit, it is in parallel with this 10 ohm resistor. And so it would have the same voltage as the 10 ohm resistor. So that would be V equals IR, or VC at infinity is the same as the voltage across the 10 ohm resistor, which is 2 amps times 10 ohms, which is 20 volts. So VC at infinity is 20 volts. So make sure the sign is right. Yes, that's plus, that's minus, because that is the direction the current is going. Okay, so now we want VC at any time greater than 0, so VC for this circuit right here. So we know that VC at time t equals VC at infinity plus VC at 0 minus VC at infinity times e to the minus t times 1 over tau. So the other thing we need is tau. So tau for an RC circuit equals RC. And R is the resistance as seen, the Thevenin resistance as seen by the capacitor. And the Thevenin resistance, to find the Thevenin resistance, I will deactivate the sources. And so I'm looking at it from the point of view from right here, from the capacitor. When you deactivate a current source, it becomes open. And so it's clear to see that you didn't really have any other choice, but our resistance is 10 ohms, so our Thevenin resistance is 10 ohms. So tau equals RC equals 10 times 2 times 10 to the minus 3. That's our capacitance. Time constant is in seconds, so this would be 20 times 10 to the negative 3, or 20 over 1,000, or 2 over 100, and I will just leave it like that for now. Well, no, I won't. I'll change it. It'll be 1 over 50. Okay, and then except, is that right? Yeah, I think that's right. Yeah, that's right. Okay, and then I will plug in to this equation right here. So VC of t equals VC at infinity, which was 20, plus VC at 0, which is 12, minus VC at infinity, which is 20, e to the minus 1 over tau is 50. Tau is 1 over 50, 1 over tau is 50, so minus 50t, or VC of t equals 20 plus negative 8 e to the minus 50t, or just 20 minus 8 e to the minus 50t, and my units are volts because I didn't have any millis or anything like that. So that is my answer.